This program is rated PG. It contains themes and scenes which may not be suitable for very young audiences. Parental guidance is advised.
Welcome to the Daily Rabbit Magic Show. Today, we are going to reveal the top 5 secrets of chemistry with my assistant, Marjorie, Bathan. Enjoy!
The cloud in a bottle experiment requires the following materials: a 1-liter bottle, warm water, and a matchstick. Pour just enough warm water in the bottle to cover the bottom of the container. Light the match and place the match head inside the bottle. Allow the bottle to fill with smoke. Cap the bottle. Squeeze the bottle really hard a few times. When you release the bottle, you should see the cloud form. It may disappear between squeezes. Molecules of water vapor will bounce around like molecules of other gases, and hence it gives them a reason to stick together. Cooling the vapor slows the molecules down, so they have less kinetic energy and more time to interact with each other. How do you cool the vapor? When you squeeze the bottle, you compress the gas and increase its temperature. Releasing the container lets the gas expand, which causes its temperature to go down. Real clouds form as warm air rises. As air gets higher, its pressure is reduced. The air expands, which causes it to cool. As it cools below the dew point, water vapor forms the droplets as we see in clouds. Smoke acts the same in the atmosphere as it does in the bottle. Other nucleation particles include dust, pollution, dirt, and even bacteria. Add 1 drop each of the 3 colors.
Ba't ba ganyan?
It's okay.
Konti lang. Oh my God. Uy!
It's okay.
Huwag mo isuto. Yan, ganyan na lang. Yung sa-drop. Yan. Ganda lang po.
Okay, done.
Yan, very cool.
Now place a drop of liquid.
Damihan mo
Now
kaya.
place
Yan,
a drop
ganyan.
of liquid dish soap on the other end of the cotton swab. Place the soapy end of the cotton swab in the middle and hold it there for 10 to 15 seconds. Look at that burst of milk. Add another drop of soap to the tip of the cotton swab and try it again.
Ganda mo.
Experiment with placing the cotton swab at different places in the milk.
Different places.
Notice that the colors of the milk continue to move even as the cotton swab is removed. What makes
It's
the
look-
stirring the milk up? Milk is mostly water. but it also contains vitamins, minerals, proteins, and tiny droplets of fat suspended in solution. Fats and proteins are sensitive to changes in the surrounding solution, that is the milk. The secret of the bursting colors is the chemistry of that tiny drop of soap. Dish soap, because of its bipolar characteristics, nonpolar on one end and polar on the other, weakens the chemical bonds that hold the proteins and fats in the solution. The soap's polar or hydrophilic end dissolves in water, and its hydrophobic or water-fearing end attaches to a fat globule in the milk. This is when the fun begins. When you introduce detergent to the milk, several things happen at once. The detergent lowers the surface tension of the liquid so that the food coloring is free to flow throughout the milk. The detergent reacts with the protein in the milk, altering the shape of those molecules and setting them in motion. The reaction between the detergent and the fat forms micelles, which is how detergent helps to lift grease off of dirty dishes. As the micelles form, the pigments in the food coloring get pushed around. Eventually, equilibrium is reached, but the swirling of the colors continues for quite a while before stopping.
Try the all-new Cloud Star shampoo. Unlike other shampoos which are very basic and more than pH 10, it can strip all the natural oil of your hair. This is pH neutral and leaves your hair moist and Cloud Star shampoo. Try it.
Supercooling cola. The materials needed are a soft drink and a freezer. Start with a room temperature soda. You could use any temperature, but it's easy to get a handle on how long it takes to supercool the liquid if you know your approximate starting temperature. Shake up the bottle and place it in a freezer. Do not disturb the soda while it's chilling, or else it will simply freeze. After about 1 or 2 hours, carefully remove the bottle from the freezer. You have a couple of different ways to initiate freezing. You could open the cap to release the pressure, reseal the bottle, and simply turn the soda upside down, causing it to freeze in the bottle. You could gently open the bottle, releasing pressure slowly, and pour the soda into a container, causing it to freeze into slush while you pour. Supercooling any liquid is chilling it below its normal freezing point without turning it into a solid. Although sodas and other soft drinks contain ingredients besides water, these impurities are dissolved in the water, so they don't provide nucleation points for crystallization. The added ingredients do lower the freezing point of water, so you need a freezer that will get well below 0 degrees Celsius or 32 degrees Fahrenheit. When you shake up a can of soda before freezing it, you are trying to eliminate any large bubbles that could act as sites for ice formation. The added ingredients cause freezing point depression.
blood flour shampoo, unlike other shampoo which are very basic and more than pH 10. It can strip all the natural oil of your hair. This is pH neutral and leaves your hair moist and blood flour shampoo. Try it.
How to blow out a candle using chemistry. The materials needed for this trick are a bowl, baking soda, vinegar, a candle, and a lighter. In the glass, mix together a little baking soda and vinegar and cover it with your hand. Now just put the whole bowl. Put the whole bowl. You're supposed to put the whole bowl.
Whole bowl.
Try not this
Bowl.
bowl. Yes.
Bowl. Bowl. You know what that means?
Bulbul.
Okay.
Light the candle. Now pour the gas from the glass into the candle. Add 3 spoons of the solution.
Right.
The candle is lighted.
Daily Rabbit Magic Show.